All right, and in our last video for this week, we're going to be taking a look at working with percentages and some other issues that happen with percentages. So with this problem, I've got a, let me move this over a little bit. We got two shirts. One says, if you were a triangle, you'd be a cute one, and the other one says, yes, I'm always right. These are silly math jokes. This shirt, the first shirt is 25% off. Second one is 30% off. Which one's a better deal? The problem with this is the way this is stated right here, if we don't look any further in the problem, we don't know, right? And why don't we know? Well, a percentage is just a piece of a larger value, a whole value. Like if it was, I don't know, if we knew what the whole shirt cost, we don't know how much that shirt originally cost, so that's a problem, right? I can't tell you which one's a better deal because I don't know how much either of these costs. So when somebody just cites a percentage without a whole value attached to it, it doesn't really have any meaning. It's like I could ask one person in the class what their favorite color is. They tell me it's blue, and I turn around and say 100% of the class is blue. Favorite color is blue. That's not correct because, again, you didn't ask everybody. You asked one person, and now you're citing a percentage. It's a big issue with percentages. But let's take a look at this, and it says, let's assume the triangle shirt is originally $22 and it's 25% off. What's the sale price? Let's talk about how most people do this, and I'm going to give you a second. Think about this. Work this problem out. We're going to look at how most people do it, and then we're going to find an efficient way or take a look at kind of a nice way to take care of this that actually, again, we're in the method of kind of communicating this and doing this in a smooth way. So a couple seconds for you to work this out. Okay, so I want to see which way you did. $22. Most people say, okay, we're going to find what is 25% of $22. And then to do that, again, we can't just multiply 25 times 22. We would need to do, 0.25 times 22, which 0.25 times 22. We also could have done 1/4 times 22, and this gives us 5.5, and this is the amount, so this would be the discount, right? And then we would take 22 minus 5.5, so $5.50. 22 minus 5.5 is equal to 16.5. So the sale price is $16.50. Now, that's a lot. That's a lot of writing. That's not great. I want to think about a different way of looking at this problem, and it's something I'm going to be encouraging you to do this week. So if you're working the problem and this is the way you solved it, I want to show you a different way, and I want you to think hard about it and try to understand it, okay? 25% off. What that means is if the shirt is 25% off, we are only paying 75% of the original. So when we are decreasing a percentage by 25, we're only paying 75% of this original $22. And when I take a look at that, 0.75 times 22 gets me right to my 16.5 or $16.50. Again, what do you think's more efficient? It's probably more efficient to look at this in terms of taking a percentage of a whole value rather than multiplying, finding the discount, then subtracting it off. because we're going to be doing multiple percentages again and again and again. We're going to be compounding percentages. So I'd like to look at what percent of the whole are we paying. So this next question, a book retails at $13.99 and is marked down 20% off, then is marked down another 30% off. Does this mean the item is 50% off? Well, the first problem with this is 50% off of what? Of the original price? 50% off of what? And you can see the error here is somebody saying, okay, 20% and 30%, this is obviously 50% off, right? Definitely. Well, that's not, I don't know that that's the case. So let's talk about this. If an item, let's say it was marked down 20%. Again, I'm going to look at this efficiently and say, all right, if it's marked down 20%, then we're paying 80% of the total. So our, I'll indicate this as our first one is marking down 20%. And how we would do this is we would say, okay, it was $13.99, but we only need to pay 80% of that price because it's 20% off. So we took the 20% off of our 100% price. And $13.99 times 0.8, I get 11.192. Now this is $11.19 with the two things. So at this point, we're going to drop that off, right? We just need to remember that this is an inaccuracy. We are we're rounding, which is creating some inaccuracy. Now, then the price is marked down another 30%. So we're going to take care of our next markdown. Again, marking 30%. Now we're going to only be paying 70% of this new price of $11.19. So now let's mark down our 30% off. So we are going to take this and it will be, so our new price is $11.19. And we are taking 30% off of that value, not my original value. It's then marked down 30% off. So we're going to pay only 70% of that price. And when I do 11.192, or sorry, 19 times 0.7, I get 7.833. And again, I can't have this 83.3 cents, so we're going to round that off. So let's see. Our price is $7.83, right? The original was $13.99. Is this 50%? Is it? Well, we can actually say, okay, this is my part, right? This is my whole. Now, when we divide these, this is going to turn it into the decimal format. 7.83 divided by 13.99 gives me 0.5596854,896. Again, this is inaccurate, but this is about 55. Let's just say it's about 56%. So it's not 50%. If we mark down 20 and then mark down 30, we are actually at 56%. It's very different, isn't it? We haven't really talked about this yet, but I want to show you how we actually compute this. If we're going to take 80% off, so we have $13.99. We take 20% off, so we're paying 80% of that. And then we're taking another 30% off, so then we're taking 70% of that. When I do this, 13.99 times 0.80 times 0.70, I get 7.8344. Again, we would round this, and you can see what we got right here is the same. I could also just say, okay, if we want to find this total discount, if we multiply 0.80 times 0.70, we get 0.56, which is the same as our 56% off. All right, I'm going to do this last one. We're just going to look at the efficient way. So let's assume the Yes I'm Always Right shirt is marked on $12 on sale. So this is the sale price, and we know it's 30% off, but we don't really know what that original price is. So how do we do that? What we do is, well, how did we calculate the sale price, or the old school way? We said, okay, I'm going to take whatever. It's like, all right, I don't know the original price, right? So I'll just call that X. And what you guys did was you would say, okay, X times 0.30, right? And then we would take that away. We would get some number, 0.30X. And then we would go, okay, X, whatever that sale price is, minus 30% of that sale price. That would get us to our new sale price, which is $12. The efficient way to think about this is if I was paying, we paid 70% of whatever the original price was, and it ended up being $12. So dividing both sides by 0.70, again, it's on that side because we don't know the whole value. And then, so 12 divided by 0.70 gives us 17.1428571. We're dealing with a dollar value here, so we're going to round that up. So this original price, it would be $7.14.